Alright guys, so we know about the axis of symmetry and the vertex of a parabola. We also know that the vertex, well this skipped ahead on me, the vertex represents the maximum or the minimum of the particular function that you're dealing with. And maximum and minimums are things that we're very interested in because, well, we want to minimize how much materials we use for a particular thing. We want to maximize the amount of revenue that we make for a particular thing. And so knowing what we do about finding the vertex and the axis of symmetry, it's going to allow us to solve some story problems where we want to maximize or minimize things. All right, so let's go through this example and show how that all comes together. Suppose that we have 1,000 feet to construct 2 dog pens as diagrammed. What dimensions give the maximum area possible for such a construction? Well, there's not a diagram. I guess I should put one up there. Ah, there we go. So there they are. They're adjoining dog pens. They're both equal in size, and so we cut the bottom into X and X, and the other dimension is Y. All right, so what we're going to want to do is get the maximum area with the 1,000 feet that we have. We want the maximum area. All right, we're going to have to start with things that we know. What are some things that we know? We know that fence would represent, in this case, mostly the perimeter. There is that one that's going through the middle, but the fence represents the perimeter, and it's basically a big rectangle, so we could calculate the area. So let's start there, and let's write down equations for each of those things. Okay. Okay, well, let's start with the area. We know that it's a rectangle. Overall, it's a rectangle. And the area can be found by multiplying base times height. And since the base is 2x and the height is y, then our area is going to be 2xy. All right, and there's nothing more we know about that. So let's go with the next equation, which is going to tell us about the fencing. Okay, the fence is going to be along the perimeter plus the divider. All right, so that's going to be a total of 4x. 1, 2, 3, 4, and 3y. 1, 2, 3. Furthermore, we know we only have a certain amount of fencing to work with. 1,000 feet. So we know that 4x plus 3y has to equal 1,000 feet. So we have two equations right now. That should say 2. We have two equations. We've got area is 2xy, and we've got 4x plus 3y equals 1,000. And you should kind of remember back from Algebra 2 that when you have two equations and two unknowns, you can substitute one into the other. So here's what we're going to do. We want to find the maximum area, and so we're going to have an area equation with just x's. So we're going to take this equation, solve it in terms of x. Actually, this one we'll do in terms of y, and then plug it in for y. All right, so when we do that, this is what we get. It's not the most appealing looking thing. 1,000 over 3 minus 4/3 x. No, that is not very appealing. But it is what it is. It's not something that isn't possible for us to do. We can do this. So we're going to substitute it into the other one. And when we substitute it in, it's going to look a little bit like this. Okay, I still have my 2x times this whole thing. I need to distribute that. When I do, I end up with this equation right here. All right, this is where the maximum and minimum comes in. What kind of graph does this look like? It is a parabola and it's upside down, which means there is going to be a maximum. If we were to graph this on an XY coordinate system, y would represent the area, x would be right here, and right there would be a maximum area, and we would be able to find out what our x dimension is that results in that maximum area. All right. To find out where the vertex is, we have to use the negative b over 2a. That's going to give us our x coordinate for the vertex, which in this case is going to represent the maximum. And again, not very pleasant looking, but 2,000 over 3 over 16 over 3. The 3's just end up canceling out when you do the math. You get 2,000 over 16, which is 125. What that tells us is that our dimensions right here and here are 125. All right, so that's 250 feet across. All right, now we need to know what our y is. And so we're going to substitute back in. Okay, our original perimeter equation was 4x plus 3y equals 1,000. That's the easiest one to plug this back into. Plug it in. We end up with 500 over 3 for our y value, which is 166 1/3. So the dimensions that are going to result in our maximum area for those wonderful dogs that we're keeping penned up is going to be 125 by 166.3. And when I say 125, I'm saying that's the dimension of one of those pens. Okay, remember, this was 125. The whole thing was 250. All right, so pay attention to how they ask the question to know whether or not you should say it's 250 by 166.3 or it's 125 by 166.3. Anyways, that's the basic idea. You're going to have two equations that you're working with. You're going to have to solve one of them for y, usually, plug it into the other, and use the vertex formula in order to find out where that is. That, my friends, is the end of this video. Adios.